In this presentation, I'm covering the process of taking the Faro scan data into Scene software. What you see, what we're doing right now is loading up the scan data into a viewable mode. So what you're looking at is called a planar mode. And what you see is on the buildings, we have these marker points on the wall. You can see these little yellow squares. So basically, Dongsu was going through each one of these planar scenes and making these surfaces, flat surfaces, as something to triangulate all the scans together. So you can see it's going through each one of these scans. It looks like a photo, but it's actually a point cloud with RGB data or photograph data on top of it. And you can see these little squares that you can see right there in the middle indicate that he put basically a planar marking surface on there. So what we're trying to do is tie in all 12 or 18 of these scans into one large point cloud. So you can see he's showing on the left side all the different points, point data, plane data, and how this is all put together. So right now what you see is basically, really quickly there, you saw them all tied together. So you're selecting them, putting them into subfolders, and those subfolders will basically be all tied up into one super point cloud. So you can see all these subfolders are broken down. So you can see it's a tedious task. It takes about up to 4 to 8 to 12 hours sometimes to tie all this data together. Usually we use spherical markers or globes out into the surface, but this was done without any globes. It was done markerless also. So he tied in just with planes and then also marker points. All right, here's on the other side of the hotel. Again, these are planar surfaces that you can see as we scroll in. You can see these surfaces. So they're going one by one. You can see each of this. So he's opening up one at a time, just kind of showcase what these look like. So right now he's showing you 4 different perspectives of that wall. So you can see those are would all line up using the software. So again, another viewpoint of a certain wall. So you got 1, 2, 3, 4 different views. And when you do all that, when you tie them all together, you can see this is one subfolder. They're not all tied together yet, but you can see how they all tie in together. This is very accurate, accurate within a hundredths of a millimeter. So the point cloud that we're getting is super accurate. So if you wanted to do measurements of shifting of the building over years or over time, this is a good way to examine it. All right. So now we've got them all tied together, not just the 3 or 4 scans. Now we have all 15 or 20 scans tied together. And you can see this is not a final point cloud, but it's ready to export as a PTS file. Okay, so as you see, Dongsu is now selecting each one of these scans, and you can see highlighted in yellow as he's going around what is indicated of what that throw of that scan. All right, so this is the second site. This is a probably more historical or more relevant scan of the plaza. So you can see, again, tons and tons of scans, and you can see just flat surfaces on the road, flat surfaces on the walls, were used to tie all this together. Again, hundreds and hundreds of markers to tie this together. You see the little yellow squares. This indicates a flat plane surface. All right, so we're going this frame by frame. Again, this looks like a photograph, but it's not a photograph. This is actually a point cloud, billions and billions of points, XYZ data, plus RGB data attached to it. So it looks like a spherical map, but it's actually just a really exaggerated point cloud. So Dongsu actually looks like he did some scanning up on the rooftop to tie all the data. So you can see the scan is actually doing pretty far scan. You can see it's going all the way across the plaza scanning. So this is almost, I would say, almost over 100 meters scan. I didn't know it could scan that far. So you can see really quickly, this is the whole point cloud or the whole scan surface. So this is all of them tied together. And so he's going to open up and you can see all the different marker points that he used from a point marker to a scanned area. So now he's just going to go to each of the subfolders and select it. So you can see scan by scan or group by group. You can see the scans. So now it's almost ready to export. So from scene, we export it out to as a PTS. And then now we're looking at this, the raw PTS file. So this is the exported artifact that you get from tying them all together. This is a very, very heavy file. It's usually about 14 to 22 gigabytes. So it's a very heavy file. You have to have a nice system to be able to open this up and to preview it. So again, this is downsampled. It's not the full viewing plane of this. In the next software we're going to use, I'm going to showcase it in Bentley software. But you can see just in the preview mode of Scene software, you've got a pretty good resolution. This is the pool area. And you notice in the pool area that the water is not showcasing the laser. Actually, it just goes right through the pool or gets deflected off into the atmosphere. All right, this is a very long-winded. We'll probably cut this down. This is for the translator. We'll probably cut this by at least 3/4. This is just a lot of filler. Um, so no need to translate all of this. We'll just kind of cut this. All right, this is the plaza area. Again, this is another point cloud showcasing what it looks like when you tie all the scans together and make a point cloud. So this is probably downsampled a little bit. It's not showing the full range here. We will probably, this is for the translator, we'll probably cut this by 2/3. We're not going to show too much of this because we'll later show this in Bentley Tools. All right, now what you see now is actually a fly-through using Bentley tools. So this is showcasing every single um, point and RGB data provided by the scan. This is in true HD, so we're flying through, showcasing every little nugget or information that we captured. So this is the exciting part, actually seeing the surfaces, seeing being able to fly through the space. So with this data, we're going to convert it to a mesh, and then we're going to retope it, hopefully have it ready for some sort of augmented reality experience using the Oculus, or maybe even using an iPad so we can actually see uh, this plaza area. This is pretty exciting. So really quickly, this is also using Bentley tools or point cloud software to kind of showcase every point cloud part of this scan. So we didn't want to show too much of this one because this was just a really simple hotel, not a historic plaza. So, but again, you can see how quickly you can go through the space. I think there was a lot of windows here. That's why they're not showing up. A lot of overhang and probably um, not a lot of scans with this project. So this is what I'm excited about is taking the scan data, we took it into Geomagick Wrap, which can convert point cloud into a mesh. See, we lost a lot of data here, but this is a good starting point for me. I can take this and start to model based on the geometry that we have for the site. A lot of these normals have been reversed. I'll have to reverse each one of these so it's facing the right way. But again, this is a great way to get started retoping it. Hopefully have one or two buildings complete so we can actually put it in UC Wynn Road and demonstrate the plaza. Again, a lot.